Imagine standing in the middle of a field on a sunny day. It's noon. The sun is high in the sky, and all around you, the sky appears bright blue. Now picture the opposite, a view from space. There are no clouds, no air, no atmosphere. The sun is still shining just as brightly, but the surrounding space appears completely black. Why is the sky blue on Earth, while space remains dark and colorless? The answer lies in how light behaves and, more importantly, what happens to it when it enters Earth's atmosphere. Sunlight may seem colorless, but it's actually made up of all the colors of the visible spectrum: red, orange, yellow, green, blue, indigo, and violet. When this white light reaches Earth's atmosphere, it collides with molecules of air, dust, water vapor, and other small particles suspended high above the surface. That's where something called Rayleigh scattering comes into play. Rayleigh scattering is a physical process in which shorter wavelengths of light, especially blue and violet, are scattered far more efficiently than longer wavelengths like red or orange. And since our eyes are less sensitive to violet light, what we mostly perceive is blue. This scattered blue light is what fills our sky during the daytime. The light doesn't come directly from the sun. It's been redirected in every direction by countless tiny particles in the air, creating the illusion of a uniformly blue sky above us. When you look straight at the sun, however, you're still seeing a white or slightly yellowish glow. That's because a portion of the blue and violet wavelengths has been scattered away, leaving behind a slightly warmer color. But the rest of the sky glows with that scattered blue light, giving daytime its familiar hue. Once you leave Earth's atmosphere, the entire situation changes. In space, there are no air molecules, no dust, no moisture. There's nothing for sunlight to bounce off of. Light continues to travel in a straight line, completely invisible unless it strikes an object. That's why, even with the sun shining in full force, the rest of space appears black. Our eyes can only detect light if it's reflected or scattered toward us, and in the vacuum of space, there's nothing to do that job. That's also why you can still see astronauts or spacecraft lit up while everything around them looks pitch black. The sunlight hits their surface directly, so we can see them, but the surrounding emptiness remains dark because there's no air to catch and scatter the light. An equally fascinating part of this story is why the sky turns orange or red during sunrise and sunset. At those times, sunlight passes through a much thicker layer of atmosphere. Most of the shorter wavelengths, especially blue and violet, are scattered away before the light reaches your eyes. The remaining longer wavelengths, orange and red, dominate the scene, producing the colors we associate with twilight. So in short, the sky is blue because Earth's atmosphere scatters blue wavelengths of sunlight more efficiently than other colors. Space is black because there is no atmosphere, no scattering, no reflection, just pure, uninterrupted light traveling silently through the void. Unless that light hits an object directly, it stays invisible. What seems like a simple question actually reveals a beautiful intersection between physics and perception. The blue sky we take for granted is the result of invisible molecular interactions happening above our heads every second. And if Earth had no atmosphere at all, our daytime sky would be completely black, with just a blazing sun against a cold, dark backdrop. It's one of those everyday wonders that remind us how even the simplest things around us are shaped by the deepest laws of the universe. The fact that our planet glows blue beneath a sky filled with scattered light is not just beautiful, it's rare, it's scientific, and it's quietly extraordinary. Subscribe us for more videos.